You might have noticed in Unit 10 that I had a little quibble with one of the exercises. It's actually exercise number 9, chapter exercise number 9 on page 395. And what it says is that in this exercise, we'll explore how well education helps explain our social attitudes. This time, we'll examine education and its association with political party identification. Calculate gamma for the table. Well, the quibble that I had with it is not necessarily that it's bad statistics, it's just kind of bad political science. Because there's a whole lot more than just education that goes into party identification. Curiously enough, the gamma actually shows that. The gamma demonstrates, in fact, that there is no real association. Let me go back to the back of the book since it's an odd number exercise, and I will tell you exactly what the authors found when they did that. Chapter 12, number 9. The gamma for the table, the gamma is 0.13. Using education to predict political party affiliation, we reduce our prediction error by 13%. This is a very weak relationship. I would almost go as far as to suggest maybe a non-existent relationship. So what I always like to do is when I see something like that is I actually study it, do a little bit more digging to see what sort of information we can have. And let me just bring over the data set. The data that they use for this actually comes from the GSS 08 PFP A file, and it's essentially party ID, which is mine are all in alphabetical orders. Nice. Party ID, and then it's also the education. Education, and that's actually a interval ratio level variable. So education in this case is the independent variable. Political party affiliation would be the dependent variable, because it's thought that education would come, in terms of time, would come before your party identification. Now, you'll have to do a little bit of extra work, and I did that. I did a recoding, and I came up with two files, one that's less than bachelor's degree and one that's at least a bachelor's degree. And it's a pretty simple process to do some recoding. You have to go to transform, recode into different variables, and what I did was I had one variable, the variable that the input variable is education, and then I just education grouped. Now you might remember if you look at the actual variable, if you do a frequency, you'll see that education could be anything from 0 to 20, I believe, and you can get that information pretty easily. So if it's less than a bachelor's degree, it would be pretty much everything from the lowest. So that's what I did here. The lowest, let me scooch this over here. You get this little window. Everything from the lowest through 15 years of education is considered to be less than a bachelor's degree. 16 through the highest would be considered at least a bachelor's degree. And so one of the things that you always want to make sure you do is I recoded this into different variables. So what it's going to do is it's going to create a new variable at the end of the list called education grouped, and you can take a look at what it looks like. Let me just do a continue here. Let me not do an OK, but let me just cancel. If I were to analyze this, take a look at frequencies. Education is already in my little space there. I'm going to put education grouped in here, and we're going to take a look at them. Now you'll notice that education by itself is 0 to 20. I was right. And so 0. And then when I did less than bachelor's degree would be the total number between 0 and 15. And then the at least a bachelor's degree would be everything above 16, 17, 18, 19, and 20. And so again, this all is sort of direct, kind of makes sense. I did a chi-square test, cross-tabulation test, and I can show you how to do that. It's actually pretty easy. You just go to Analyze, Descriptives, and you're going to do a crosstabs. Remembering that party ID is the row, which would be the dependent variable, and then education grouped is the independent variable across the columns. And so when I did statistics, since it's asking for a gamma, let me bring this over here. Since it's asking for a gamma, you have chi-square, contingency coefficient, phi and Kramer's V, lambda, and I selected gamma. So I will click on continue, and this time we'll take a look and see what it does. It creates some output, which unfortunately is in the other monitor. So I'll move it over here. You have just some case processing. There are 1,491 cases, and it shows the less than bachelor's degree. You could, if you wanted to, essentially take these strong Democrat, not strong Democrat, independent, near Democrat, and maybe code them as Democrat, independent, and then independent, near Republican, not strong Republican. You sort of combine those, but I just kept them separate. And what you see here is that the folks who have less than a bachelor's degree, about 18% are strong Democrats. Those that have at least a bachelor's degree, 21%. And there doesn't really seem to be that much of a pattern there. And then once you do all of this, you'll see there's very little pattern. Cannot be computed because the asymptotic standard error equals 0. There's issues related to math. But even your gamma, if you take a look at your gamma, your significance in your gamma, it's a really tiny significance. The difference is that it looks like when they did the study, which is a different study, they combined all the Democrats and all the Republicans, and that could be done. I mean, it's pretty straightforward. What I wanted to do is maybe take a closer look at something like maybe gender. So what I would do is go to data, and we're going to split the file like it tells you to do for a couple of the other assignments. And we're going to organize this output by groups. And I already have sex in there. So it's going to separate it out by male and female. If I click on OK, it'll give me some more output. Now what it'll show you in this output, if I can find it, first of all, it just does it. Sort cases by sex, split, separate by sex. Then you actually have to do the analysis again. So you just go back to compare descriptive statistics, crosstabs, party ID, education group, it's all the same. Click on OK, and now it'll actually give you the information here. So you'll scroll down a little bit. Actually, you probably have to scroll up a little bit to see the case. So this is what you just did. You did a crosstabs, so just on sex. And what you see is interesting is that it doesn't really matter in terms of males and females, or in terms of education in the male group. 15.7% of folks with less than a bachelor's degree are strong Democrats. 15.6% with at least are strong Democrats. And you always want to look at the percentages because you notice the absolute values are really significantly different. Part of what's really interesting is here's the percentage of the men that actually have bachelor's degrees is a little bit lower than the percentage of the men that have less than a bachelor's degree. So we take a look here. We see lambda. Lambda's not significant. Chi-square is not significant. Gamma's getting close to significant, though. If you notice here at the 0.06, you're looking for a 0.05 or lower. Let's take a look at females. Females, it does appear to make something, a tiny bit of a difference just looking at the chart here, sort of the eyeballing it. Women that have less than a bachelor's degree are 21.6% of those are strong Democrats, whereas 27.4% of those who have at least a bachelor's degree are strong Democrats. Let's take a look at strong Republicans. Again, there's not a whole lot of difference there. We do have a chi-square because it's significant, 0.036, so there is a relationship. The other measures indicate a relationship. Lambda is problematic, but even among gamma, there isn't a whole lot, and in sense, it's actually a negative number. So that's one of the things that I wanted to do. You can also take a look at various religions, how that works together in terms of religion. But what I was quibbling with on the authors and that exercise was it's just too simplistic to say that education will affect party identification.